So in the question, they've given you the transfer function as being this, right? Now what you want to do is you calculate the poles of this denominator. So using the determinant formula, I can find out the poles of this transfer function as being um, minus 6 plus minus b squared minus 4ac, so 36 minus 4 times 34 divided by 2. You will notice that this will give you plus minus 10j on 2, which is equal to minus 3 plus minus 5j. Now once you have that, you also notice in the question they've given you, they want the compensated pole to be at minus 4 plus minus 3j, yeah, 3j. And they've already given you a leading pole which is of value minus 25. Now you do your plot over here. So let me just get that. So let's say your minus 25 is here, and your minus 4 is here, and your minus 2 is here, and your minus 3 will lie somewhere here. According to this, your 5j is here, and your negative 5j, let's put that here, and you've also got a 3j. Okay, let me use a different pen to make things easier for us. Now, you have got this pole which you, so you have got a pole here, right? There's a pole at minus 25, and then there is a pole at minus 3 plus 5j and minus 3 minus 5j. Notice the conjugate of minus 4 plus 3j, because there's a minus 4 minus 3j, right? It lies directly below, so it doesn't contribute any angle to this pole because it contributes only 90 degrees. We don't take that into consideration. However, we do take into consideration other singularities. I forgot to add one more singularity here, that is a singularity of 0. Now what we want to do is basically calculate the angles contributed by other poles or other singularities like other zeros to this pole at minus 4 plus 3j. And if only Siddharth can wait, that would be really nice. Okay, sweet. Now what we want to do is basically, so we want this angle and we want this angle. Notice we always take angle from the positive axis, and we want this angle. So if you were to draw a little diagram here, you would want this angle. Actually, this is just making it messy. So you would want all the way this angle, and you would also want the angle contributed here. Okay. In order to do those calculations, I've already basically, in the end, you would end up with something that looks like this. You would end up with equation that says, so we subtract the poles and we add the zeros. So this angle here, which is θ1, amounts to minus tan inverse of, you notice that this, we always take the opposite over the adjacent. So this ends up being 3 on 21 because you're rising by 3 here. As you can see, 3j, so you're rising by 3 units and you're running by 21 units, and plus, because now we consider our 0 here, what I'm doing here right now is I'm doing 180 minus tan inverse 3 on 2. I notice now that I should have used a different pen, but we'll go with the flow now. Right, so that's this angle, the θ2 angle. We're adding the 0. And basically over here what I've done is simply calculating this angle, and I'm subtracting that from 180 to get my θ2, and I'm subtracting the pole over here, which is minus tan inverse of which is minus. So as you can see, if I go from here to here, and so angle from this point to this point is 270 degrees. So I'll simply subtract this little angle from 270 and get my obtuse of my angle over here, which is going to be minus simply tan inverse of a half. And notice we have to make sure, remember, we have to calculate this pole as well. And that pole is simply going to be 90 degrees plus this little angle. And that is given by tan inverse of 1 on 10. Notice, because this and this is 10 units long and this is 1 unit wide, so I can sort of calculate this angle and add a 90-degree angle and get my contribution towards from this pole, which is minus 4 minus 3j, to my pole of minus 3 minus 5j, and see the contribution it makes to the pole at minus 4 plus 3j. And once you do that, you end up getting 225 degrees, if I'm correct, according to my calculations. Let me just verify. Yeah, you end up getting you end up getting minus 225 degrees, which suits our purposes fairly well. In order to get the angle, now we want our root locus to contribute. So what we want is a 0, some angle that is contributed by 0. So the sum of all these angles is minus 225. Now this equation this problem becomes very simple. What we want is that this angle plus the angle that is going to be contributed via our 0, which we are going to calculate soon, should be giving us minus 180 degrees. Now you can easily use fairly simple linear algebra and get that your ZC amounts to be 225 plus 180, which is 45 degrees. Now here is what the magic comes in. Don't ask me any questions as to how I did it, but it's fairly easy. All you have to do now in the next equation, just simply write down the imaginary part of your dominant pole is 3. So I'm going to do this in blue. 3 divided by the real part of your pole, which is minus 4. Take the absolute value, 4 minus, this is going to be our 0. This is going to be a ZC, or sigma in this case. I'm going to write ZC here so that you don't get confused, is equal to tan of 180 degrees minus 45 degrees. This 45 number comes from here. And you can solve for ZC, and this comes out to be 7. And this is your location of the 0. So that was fairly easy. In my next video, I will tell you how to calculate the gain. That is, if I am able to solve for it.